Hi, my name is Jeff Bostwick. I have an invention for ski and snowboard binding suspension that I want to show you. I'm looking for partners. It is currently patent pending, but I'm trying to move it from a prototype model to a production model. So a little bit about me. My company is Terrain Park Consulting. I design and build snow parks. I've been all over the world, operated all types of different machines, and built all kinds of jumps and rails. Uh, I teach this. I teach the 3D modeling of it. This type of stuff here. I also have another company that's called Tutors and Services, in which we provide all types of help with 3D modeling and architecture, mechanical product designs, game designs, anything under the umbrella of 3D modeling. We are tutoring, and we also provide freelance services. So traditional bindings have foam underneath your foot, and as well as foam below your boot. And this is kind of problematic for a couple different reasons. You want to have a direct connection between the interface, you and the board. So the interface is the binding, and any type of squishiness between your foot and the board causes there to be play and to be movement. And a lot of riders make up for that. Let's say you're riding half pipe, you're riding tight trees, you need to have a really quick response time between your heel to toe. You don't want any squishiness in there. So what I propose is that we take out the padding below your foot. We also thin the sole of the boot to make a more direct connection. Now, where do we have that suspension is now placed below the binding. The problem with that, and I've seen this in some other binding suspension systems that have come out in the past, the problem with that squishiness is that the same problem. We've now lost that edge-to-edge connection, and it's all squishy and not responsive. So my solution to that would be to have these vertical pins that will constrain the movement of your binding to the up and down direction. So your binding only moves up and down, riding on those pins. So if you lean back, let me show you how this works. If you lean back or forward, you have a direct one-to-one connection to the board. Yet, if you were to land hard, straight down, there is still cushion below your feet. So this is how it works. There's 3 cylinders that are welded together. We've got a Teflon embedded cylinder here, which has a very low coefficient of friction with steel. So it's a bronze bushing. And basically this piece is T-bolted to your binding. So this is how it looks. On the top, these 3 cylinders are T-bolted, connected to the side of your binding. And this Burton binding, it fits right in this side connection here. So in between, once you have that set up, this pin kind of rides in the vertical direction and constrains that movement to only the vertical direction. In between the binding and the board, you can put springs, you can put foam. I tried a bunch of different setups. This is a prototype, so it's a little sloppy, but a production model would be a little more cleaned up. So basically in this video, this is one of the prototypes. I had kind of a longer pin here. And as I put a lot of pressure down in the binding, it moves. The newer one I have has a smaller pin, so there's less movement. It rides just like a normal snowboard, with the exception that if you land really hard on your heels, you'll feel that impact a lot less. It'll be a little bit softer. I have a knee injury, so I have ridden this for the past 5 years. I ride this prototype. I wouldn't ride without it. It lets me keep going with that, that chatter, prevents the pain in my knee. Landing hard, it helps. So some applications of this, elders, you continue to ride without the pain. There's an aging demographic of riders, and especially park riders, that have some injuries. If you're nursing injuries back to health, this can kind of help that transition. Anything where you're impacting, ankle, knees, hips, spine. It prevents injuries if you're a healthy rider. A single traumatic experience. I landed really hard on my heels, actually on the landing, but just hard pack on my heels, and that's how I hurt my knee. Or repeated impact, things like shin splints. Testing jumps for the first time, guinea pigs. It takes a little bit of guts to go, and you could land short, you could overshoot, and this just reduces the risk of injury slightly. So, it could keep you from blowing out a knee. Making ice feel like powder, a little bit of an exaggeration, but it does make those icy conditions feel a little bit more comfortable, a lot less of that heel chatter, less impact when you land. And the business case is, why would I even buy new bindings if mine are perfectly good? Well, the only reason to buy new bindings is if something's better about them. People are willing to spend money on something that protects their own bodies or their kids. Parents especially, seeing kids in the park and get a little nervous, and anything to protect them is worth spending money on. Okay, the ski application is basically the same. You've got a plate underneath the binding that your foot rests on. The pins fit in the same way. There's foam and springs underneath. The only difference I have in this invention potentially is, a pin that hinges this way. This could be on the ski or the snowboard invention. As the ski flexes, those pin directions are going to change. Now, I don't want those pins to be flexing left to right, edge to edge. I just want them back and forth. So as a ski flexes, that pin moves with it, and that makes that fit between the pin and the cylinder a little bit more fluid, and movement is not restricted as that ski flexes. So the same thing could happen on the snowboard binding as well, just in the other direction. So if this is interesting to anybody, please reach out to me at jeff@terrainparkconsulting.com. I'd love to talk about it more and partner with you, or get help from you, or help you. Whatever works, I'd like to work together. All right. Thank you very much.